topic for today's discussion is hypertensive disorders of pregnancy, or what we call as HDP. So we start with this hypertensive disorders of pregnancy. So let's try to understand what is blood pressure basically. Blood pressure is a pressure which the circulating blood exerts against the walls of blood vessel. All right. Suppose this is a blood vessel, okay, and we have blood flowing through this. Say we presume this to be red color blood. So whatever the pressure this blood exerts on the walls is called as blood pressure. All right. And this vessel has its own elasticity, and elasticity means it has its own it has its own blood the muscles, they also exert, and that is called as vascular resistance or peripheral vascular resistance, whatever you call, right? So this means when blood is going through the vessels, any pressure which it exerts on the walls of the vessels is called as blood pressure. Now, what is the blood pressure equation? It is cardiac output into vascular resistance. This is what we know from our physiology. Now, coming on to the cardiac output is heart rate into stroke volume. Now, further we divide. So, blood pressure comes to heart rate into stroke volume into vascular resistance, right? So that we have three parameters now. And what is a stroke volume? Stroke volume is the amount of blood a heart pumps in during one contraction is called as a stroke volume. This means once we have a diastole, any blood which is there in the heart at the end of diastole is called as end diastolic volume. And after the systole or after the contraction of the heart, whatever is left is called as end systolic volume. This means the difference between the two, the end diastolic volume and end systolic volume is your stroke volume. Okay. Now, so how do we measure blood pressure then? How do we measure blood pressure then? So we suppose we have heart rate which is say 60, okay? And we know that stroke volume is approximately 70 to 80 milliliter, okay? And suppose we take as 80 milliliter, and then vascular resistance we see later on. So this means 60 into 0.08 is equal to your cardiac output, okay? Because your heart rate and stroke volume is equal to your cardiac output. So we suppose take 60 and multiply by 0.8, okay? So 480, say 60 into 8 is equal to 480 divided by 100. It comes to approximately 4.80, okay? So this means your cardiac output here is 4.8 liters. All right. Now coming on to what we know is we have to multiply this with the vascular resistance. Now vascular resistance is say diastolic resistance is 14. Now if we multiply 14 into so we take 5 from here, no? Let it be a rough figure, 5. So 14 into 5, 5 4s are 20, 5 and 7. So this means this 70 is your diastolic blood pressure. All right. Clear? So the next thing what we are interested in is how to find out the systolic blood pressure. For that we have say this is say 5 only. Let it be 5. Your cardiac output is 5 liters. Now we have to multiply this 5 by a resistance, no? Now diastolic resistance was 14. We multiply 5 into 14, that comes to 70. This means this is your diastolic blood pressure. All right. The next is your systolic resistance. So if we multiply 22 into 5, that comes to 5 to the 10, 5 to the 10, and 1, 11. This comes to 110. So 110 is your systolic BP. So this means we have 110 by 70 millimeters of mercury is your blood pressure. So this means what do I have? If we have in a normal circumstances, if I have only heart rate with me, and we know that stroke volume is most of the time say 80 ml per, this thing. Rest, these are the standard values which we have. So once we know heart rate, we can find out about the blood pressure. Okay. So another thing which we are interested in is what is a mean arterial pressure? Okay. Now coming on to the next is your mean arterial pressure. Mean arterial pressure means the tip of systolic pressure and the diastolic pressure. This mean arterial pressure is somewhere in between, no? And how do we calculate? We multiply diastolic blood pressure by 2, then systolic blood pressure divide by 3. So this total, say this total divide by 3 comes to be a mean arterial pressure. And in mean arterial pressure in normal circumstances is 70 to 100 millimeters of mercury. And this is most important thing. More important than even systolic and diastolic taken separately. So this was a blood pressure equation. So now how is blood pressure controlled in pregnancy? What are the factors which control blood pressure in pregnancy? If we go back to this slide, so what can be one is the pressure means say how much blood we have or the blood volume. That is one important. And another point is vascular resistance. So these are the things which control your blood pressure in pregnancy. So say plasma volume. Okay. Now, plasma volume is taken care of by a renin-angiotensin system, which we all know from our physiology. Let's just try to recapitulate what happens. The corpus luteum and placenta, they produce a hormone called as prorenin. And placenta and ovary together, they increase estrogens. And estrogens then enhance the production of angiotensinogen from liver. So now we have two things: prorenin from corpus luteum and placenta, and angiotensinogen from liver. Now, renin is also released from the kidneys. Renin and prorenin convert angiotensinogen into angiotensin 1. This is important. Now, so what happens then is, then there is a angiotensin converting enzyme which is released from the lungs, right? It acts on angiotensin 1 to convert into angiotensin 2. Now, what does angiotensin 2 does? It does is it directly acts on the blood vessels, stimulating vasoconstriction. So, okay. So the blood vessels are like they are constricted. Okay. Secondly, it acts on the adrenal gland to stimulate the release of aldosterone. Okay. Basically, this all started when there was a drop in blood pressure and drop in fluid volume. So there was renin produced from here and then prorenin from here, all these things. So at the end, the result was angiotensin 2 causes the vasoconstriction and it causes the release of aldosterone. Now, what does aldosterone do? Aldosterone acts on the kidneys to stimulate reabsorption of salt and water. So once it reabsorbs salt and water, the end net result is there is increase in blood volume or plasma volume. Okay. So this is one controlling factor, how blood volume or plasma volume is controlled during pregnancy. Another thing is, once there is, say blood volume is increased or there is a cardiac distension, it causes stimulation of and production of atrial natriuretic protein and brain natriuretic protein. These are two proteins. They basically cause vasodilatation vasodilatation means there will be a decrease in blood pressure. So any condition where there is increase in blood pressure, it causes a distension of the heart. That causes release of these things. They lead on to vasodilatation, and your blood pressure is decreased. These two things also cause a decrease in renin. Again, we understand that if we have increased renin, it was causing increase in blood pressure or increase in plasma volume. Once it is decreased, there is decreased angiotensin 2 and aldosterone. So that will further, act on the kidneys. So there will be a natriuresis and there will be a decrease in blood pressure. Okay. So during normal pregnancy, these plasma ANP and BNP are maintained in non-pregnant range despite greater plasma volume. But BNP levels are elevated in severe preeclampsia, and this may be caused by cardiac strain from increased afterload in the heart. Okay. Another important thing which we always talk about is endothelin 1. It is a potent vasoconstrictor produced by endothelial vascular smooth muscles. Its production is stimulated by angiotensin 2, arginine, vasopressin, and thrombin. So endothelins in turn stimulate secretion of, again, atrial natriuretic protein, aldosterone, and catecholamines. This may be looking boring to you for some time, but we have to understand these important things because that helps us in understanding the basic pathology later on. Okay. So vascular sensitivity to endothelin is not altered during normal pregnancy, but it is pathologically elevated in preeclampsia. So this means what we had was, one is we had a renin-angiotensin system which was controlling. Another is at ANP and BNP. And third is endothelin. In a normal pregnancy, we all know there is a balance between prostacyclin, that is PGI1, and and thromboxane TXA2. All right. So it is the prostacyclins, they take over, and this is a causes vasodilatation. Platelet aggregation is less. So uteroplacental blood flow increases. All right. Whereas in preeclampsia, there is a reverse mechanism. This means the thromboxane 2 overtakes, and this causes activation of coagulation system, and there is angiotensin 2. They all that is increased. They all cause a vasoconstriction. All right. If an endothelin is causing vasoconstriction, then there are anti-angiogenic factors. This will come to again. I will come to these two again. Right. They're important because these two things are now possible by if we measure these things, we can probably they are factors which are important in predicting the development of preeclampsia. Another factor which is important is the nitric oxide. We all know that this is a important vasodilator. So what happens in pregnancy is IH or PET, whatever you call it, they are increased. They are decreased. Sorry, they are decreased. So this means that is another factor which is causing vasoconstriction. All right. Now this is important. This is a soluble FMS like tyrosine kinase 1. It is basically a protein with anti-angiogenic properties. Remember this thing, it has anti-angiogenic properties. This means it is counteracting VEGF with VEGF, right? So this causes growth of vessels. So this acts against this, so it does not let vessels grow. Vessels do not grow much. So in preeclampsia, this is increased. All right. That's right. So abnormally high levels of this have been implicated in the pathogenesis of preeclampsia. Now, why and how all these things happen, we'll come to that later. Okay. Now let's understand what are the normal cardiovascular changes which occur in pregnancy. There is a decrease of 4 to 6 millimeters of mercury in systolic blood pressure. There is a decrease of 18 to 15 millimeters of mercury in diastolic blood pressure. So mean arterial pressure decreases by say 6 to 10 millimeters of mercury. Heart rate increases by 12 to 18 beats per minute. Stroke volume increases by 10 to 30%, and cardiac output increases to say 33 to 45%. And all these things, they bottom around 20 weeks, right? And like say, I'll tell you that growth will come, just hold on. So now what are the changes trimester wise? In first trimester, there is a cardiac output increases, systemic vascular resistance decreases, heart rate increases. This is all in normal pregnancy. Blood pressure decreases. In second trimester, it increases further, cardiac output increases further, vascular resistance decreases further, heart rate increases, blood pressure decreases. And this happens, they try to come back to normal in third trimester. So every arrow means 10% increase or 10% decrease, depending on if it's up or down. Now, what happens is all these things, they decrease during the first trimester, reaching its lowest point around 20 weeks. No, this is 20 weeks. So it comes like this, and then they almost plateau or try to come back to normal, what was, pre-pregnancy levels or at the beginning of pregnancy. So this is a systemic vascular resistance. This is your mean arterial pressure, and this is your cardiac output. All right. So this is like it grows like this, then it almost plateaus and till term. Same. This is in a normal weight. Say it is 20. It is up to like this. Then it slightly increases again. Tries to come back to normal near term. Another important thing which one has to understand is how do we measure blood pressure? Once we understand, like many times we measure it during supine position or left lateral recumbent position. There is a difference. If we measure in left lateral recumbent position, your systolic as well as diastolic blood pressure, they are slightly less than if we measure it during a supine position. So this is important. One has to remember while measuring the blood pressure of a patient.